Good morning, Northridge. I'm Kim, and today is December 1st, 2010.
Good morning, I'm Jose. Today's latest news is the 2010 census data. Every 10 years of census data is conducted. The first national census in the United States was conducted in 1790. The U.S. Census Bureau is responsible for collecting and providing data of the number of people living in the United States. And based on the population of each state, a certain number of reps is given to that state.
The method of apportionment we use and have used in the U.S. since 1941 is the Huntington-Hill method, proposed by Edward Huntington and Joseph Hill. This method makes the representatives' shares as equal as possible, measuring relatively.
As you can see the map, the states in green have gained a representative, the states in purple have lost a representative, and states in blue did not gain nor lose a representative. The law requires that the census be on or about April 1st, 1980, and every 10 years after that. The returns will be made available within 9 months in order to apportion members of the House of Representatives to each of the states.
In the prevailing years, the laws requires the Census Bureau to gather statistics about the residents of the United States for use by Congress. Also, for every 30,000 people, there is at least one representative. Also, as many of you viewers must be noticing, a lot of the states from the East Coast are losing reps, and a lot of the states in the middle are gaining reps. This is all has to do with the increase and decrease of population.
With more people living in certain states, there is an increase in population and therefore an increase in reps, possibly, and that increases over 30,000.
And now Congressman Luis Garcia will join us to explain how it is determined which states gain and which states loses a rep.
Good morning, Congressman, and thank you for joining us today.
It's my pleasure, and thank you for having me here today. Well, you see, Kim, we didn't always use the Huntington-Hill method. However, the U.S. uses it because it's one that works best in our country. Now, the math is not very simple. However, in order to determine which states gain and lose is to, step 1, calculate the standard divisor. Given the divisor, we are able to calculate the state's quota. Step 2, calculate each state's quota. State population divided by total population times house size equals the number of representatives.
Now, many of us are wondering how the numbers of representatives a state gets is determined.
You will initially assign a state its lower quota, which means the lower fractional part. Once you have assigned the lower quota, then you assign a state its upper quota. In other words, ran down or up based on geometric mean. Finally, check to see if the sum of the quotas is equal to the correct number of seats to be apportioned.
That makes sense, and it seems logical. But is there anything wrong with this method? Does it have any violations?
In some instances, this apportionment method leads to the Alabama paradox, and in some cases to a population paradox. The Alabama paradox is when the house size goes up, but one or more states loses a seat. The population paradox is a state whose population decreases gains a seat, and a state whose population increases loses a seat.
That makes sense, and it seems logical.
We have a method so that we are able to calculate the population sizes, and the method is not going to make all states happy, but it makes things as equal as possible. Thank you for being on our show once again, Congressman Garcia. I guess we have to wait until 2020 for the next census data. Well, viewers, that is all we have for today. Catch us on our 5 o'clock news later today. We have a method so that we are able to calculate the population sizes, and the method is not going to make all states happy, but it makes things as equal as possible. Thank you for being on our show once again, Congressman Garcia. I guess we have to wait until 2020 for the next census data. Well, viewers, that is all we have for today. Catch us on our 5 o'clock news later today.